My name is Yea-Seul. I'm an assistant professor at U.Medicine. This work is in collaboration with Hofman and Dan Goldstein in Microsoft Research. So as the world becomes more data-driven, people are increasingly exposed to statistical information about uncertain outcomes. But how well do readers understand the effect size? What's effect size? Imagine two different experiments showing that the treatment group who drank green tea had reduced bad cholesterol by 2.2 milligram on average. So one experiment showed that the outcome of the treatment group varies a lot around the group mean and considerably overlap with the control group who didn't receive any treatment. In another experiment, the outcome of treatment group seems less varied and less overlap with the control group. Statisticians call this measure of outcome variability of the treatment as effect size. While understanding effect size can impact your decision, communicating this measure is not a simple task, and even worse, most of the time, article omits any information regarding the outcome variability. So in this work, we explore several research questions. First, how effective do people think a treatment is when the treatment is summarized only in terms of its average effect? And second, how do these initial perceptions change after people are presented with information about effect size? And in the third study, we try to see if showing more information can make people's perception more accurate. And in the last study, we wanted to check how robust our findings are. I'm not going to present study 3 and 4, but please refer to our paper if you're interested in. To address these research questions, we presented our study with an imaginary scenario of playing a game using a boulder. Participants were told that they are athletes competing against an equally skilled opponent named Blorg. To win this game, you need to slide your boulder further than the opponent's, and you have a chance to rent the premium boulder that slid further than the standard boulder that Blorg will use. We then ask how much you're willing to pay for renting it and the estimates of probability of winning if you rent. Both questions approximate the perceived effectiveness of the premium boulder, the effect size of the premium boulder, and the premium boulder is a treatment in this case. In our scenario, we set the effect size of the premium boulder to be small, since this is the most prevalent case in the news articles and scientific papers. In the first condition, we simply show a directional statement illustrating the fact that the premium boulder slid further than the standard boulder that Blorg will use on average. Then we ask two different questions. We ask how likely is it for you to win with premium boulder when Blorg uses a standard boulder. Also, we ask how much you'd be willing to pay to use the premium boulders. We have 4 more conditions that explain the performance of standard and the premium boulder. In the absolute difference conditions, participants saw the statement the premium boulder slide 4 meters further. In the percentage difference conditions, we show the premium boulder slide 4% further. In the statistical significance condition, we described a 95% confidence interval and the average sliding distance for 2 types of boulders. In the last condition, we showed the visualized confidence interval alongside the textual information in the statistical significant condition. We ran this study on Amazon Mechanical Turk with a total of 750 participants. So this visualization shows the result of the chance of winning. The x-axis represents conditions and the y-axis represents error. So being close to the 0 means that participants in that specific condition perceive closer to the ground truth. So when we illustrate the performance difference and percentage difference, participants' perception were closest to the ground truth answer. However, participants in a condition where the 95% confidence interval presented with the visualization overestimate the true effect size more than any other conditions. It was alarming because they are the most commonly used format in scientific papers. We observed a similar pattern in error in willingness to pay. In study 2, we investigate whether we can fix this overestimation problem by showing information about outcome variability. In study 2, first we show statistical significance with a confidence interval visualization, which led the most error in perception in study 1. And this was the same for all the conditions. Again, asked the same questions about the chance of winning and willingness to pay to infer participants' perceived effect size. And then on the next page, we varied to show information that directly and indirectly illustrates some form of outcome variability. In the categorical condition, we described how small the difference was between the standard and the premium boulder. We aim to replicate how the Cohen's-d effect size is often communicated using terms like small, medium, and large effect size. We compared their initial response to the revised response after seeing the outcome variability stimuli to see if these interventions help alleviate the overestimation problem. In variance condition, we state the variance that participants could sense how the outcome from two boulders can be varied. In the probability of superiority condition, we said how likely the premium boulder would win if the game is played 100 times. As you notice, this condition is directly giving the participant an answer to the chance of winning. Therefore, we only use the willingness to pay as a measure in study 2. Next, we provide a height analogy that participants might be familiar with. We're inspired by Cohen, who introduced the measure of a standard effect size. He actually used the height analogy in his book, explaining how small effect size can be translated into the height difference between 15 and 16-year-old girl. We formulate one more analogy condition that used the weather in New York City as well. We ran this study on Amazon Mechanical Turk with 1,800 participants. In this study, we only compared the willingness to pay, since the chance of winning was one of our stimuli to communicate effect size. The length of the arrows indicates how big adjustment participants made from their original misperception, measured by willingness to pay. The dotted line represents the ground truth. The probability of superiority, which essentially describes the chance of winning, and height analogy and variance reliably reduce error in willingness to pay. Study 3 looks into whether the pairs of effect size information can further alleviate misperception, and study 4 demonstrates the robustness of our finding. You can refer to our paper for further details. In this work, through multiple studies, we demonstrate that the common ways of summarizing mean difference, such as absolute difference or 95% confidence interval with and without visualization, can cause overestimation of treatment effectiveness. So showing probability of superiority can be effective to alleviate the overestimation. More importantly, the analogy can be about good as stating the probability numerically. If we translate our study results into the probability of superiority, there was a 62% chance that people who received outcome variability information made better inference than those who did not. And this is about equal to the probability among American women that a randomly selected 18-year-old is taller than the randomly selected 13-year-old. All right, thank you for your attention, and I'm happy to take any questions.